Hello students, we are doing with the homogeneous equations. When the given differential equation is a homogeneous equation, how we have to find the solution? That thing we have to do, right? So what is the procedure? So first of all, we should recognize the given equation is a homogeneous equation. So first of all, the given equation will not be in a variable separable form, right? We cannot separate x variables into dx, y variables into dy. In such case, we have to check whether the given equation is homogeneous or not. How we will find whether it is homogeneous or not? In x place you take kx, in y place you take ky, right? So f of kx comma ky is equal to k to the power of some alpha into f of x comma y we have to find, right? If we get that equation, we can say that the given equation is homogeneous equation with degree alpha. In alpha place we can have 0, 1, 2, 3, anything. Okay, once it is homogeneous, it is decided as a homogeneous equation, we can take y is equal to vx, then dy by dx we will take, and we in the original equation in dy by dx we will substitute, and in y place we will substitute vx and we will solve the equation. Okay, so that is the procedure. So come on, this is the given equation. So take the question, if the solution of this equation passes through the point, find the solution. So first you take what is the given differential equation. Given differential equation is, what is it? X into sine square y by x dx, right, is equal to y dx minus x dy. Okay, so dy is minus sign, dy is having x, dy term is having negative sign. So bring that one this side and send this value that side, so that all the dx terms will be one side. So it is x dy is equal to y dx minus, come on, we can write that as x sine square x sine square y by x into dx. Okay, so we can take dx common, so it is y minus x sine square y by x into dx we can take. So now you take, this is your x dy, bring this side, so dy by dx is equal to y minus x sine square y by x by x we have to take. You consider that as 1, equation number 1. Okay, dy by dx is equal to y minus x sine square y by x. We consider this as equation number 1. Now you take your function f of x comma y, right, is equal to, what is that? It is nothing but y minus x sine square y by x by x. Okay, so now you take f of kx comma ky. So is equal to, wherever x is there kx, wherever y is there ky we have to take. So it is ky minus kx sine square, come on, ky by kx by kx. Here kk cancel. So from this we can take a k outside. It is y minus x sine square y by x by kx. Okay, so we can write this as f of kx comma ky is equal to, come on, k to the power of 1 minus 1, 0 into y minus x into sine square y by x we can take. Okay, so is equal to k to the power of 0, it is f of x comma y, f of kx comma ky is equal to k to the power of 0 f of x comma y. Okay, so what is this? So it is therefore 1 is, what is which equation? Homogeneous equation. Homogeneous equation of degree, right? What is the degree? 0. It is homogeneous equation means once it is confirmed homogeneous equation means we have to take y is equal to vx. So differentiating with respect to x on both sides, dy by dx is equal to d by dx of vx. Okay, so it is dy by dx is equal to v into d by dx of x plus x into dv by dx. So what is the value of dy by dx? dy by dx is equal to, d by dx of x is 1, right? So it is v plus x dv by dx. Okay, so come on now, therefore from 1, what happens? Dy by dx place we can take v plus x dv by dx is equal to, come on, how we have to take? In this wherever y is there we have to take vx, right? So vx minus x sine square, come on, y is vx by x by x. Okay, so come on, how we can take here x cancel and upwards we can take x common, then it will be v minus sine square v by x. X also cancels. So you are having v plus x dv by dx is equal to v minus sine square v. V cancels. Okay, so after v cancels, if you observe dv is there, dx is there, this side v term is there, x term is there. So we can go for variable separable methods. V terms into dv and dx is downward, send that side and send x also that side. Okay, so in all these homogeneous problems, after substituting y is equal to vx, right, when we will take y is equal to vx, once the confirmation is over that the given equation is homogeneous equation, then we have to take y is equal to vx and with that y only we have to find dy by dx. Okay, once we got dy by dx and y is equal to vx, we will substitute in the original equation. After the substitution and simplification, what happens? Our equation will be in variable separable form. V terms dv, x terms into dx we can write. That means only v terms will be there, x terms will be there, not x and y terms, right? After the substitution of y is equal to vx, right, your equation contains v terms and x terms, v terms into dv, x terms into dx. Okay, so then we have to go for variable separable form. So here dv is there, so bring this term to this side. So what happens? Minus 1 by sine square v, right, sine square v dv is equal to, it is dx by x. Okay, so once variables are separated, we have to take integrals. Okay, so is equal to, it is a minus, come on, 1 by sine is cosec, sine square is there, so it is cosec square v into dv is equal to log x. Okay, and integral cosec square v is minus, right, cot v. Okay, so it is cot v is equal to log x plus C. So is equal to cot V is equal to log x plus C. And what is V? V value is always y is equal to Vx in our homogeneous problems. Whenever y is equal to Vx, V is equal to send x this side, that is y by x, right? Cot of y by x is equal to, it is log x plus C. Okay, is the solution, given that this solution passes through one point. Okay, so given that solution, right, solution passes through which point? 1 comma pi by 4, right? That means wherever x is there, there we have to substitute 1. Wherever y is there, there we have to substitute pi by 4, right? So you consider this as a second equation. Then 2 will be, what happens to our second equation now? Now you substitute cot of, in y place it is pi by 4, in x place it is 1 is equal to, it is log of x place 1 x coordinate plus C. So it is nothing but cot pi by 4, isn't it? And log 1 value is 0. It is standard formula. Log 1 value is 0 plus C. And pi by 4 means 45. Cot 45 is 1, right? So 1 is equal to C. So we got C value as 1. Okay. So therefore required, what is that? Solution is, required solution is, what is your solution? It is cot of y by x is equal to log x plus C value is 1. That is the answer of your question. Okay. So now observe carefully how we have taken the values. Here it is given that the solution of this differential equation passes through 1 comma pi by 4. Then find the solution is the question asked. Okay. So first given differential equation is x into sine square y by x dx is equal to y dx minus x dy. Okay. So if you observe, we are having the dy term in a negative sign form. So make that as a positive, bring this side, right? So x dy is equal to y dx and sending this term that side. So here dx is there, here dx is there. So we can write a dx outside. Okay. So it is x dy is equal to y minus x sine square y by x dx. So bring dx that side, dy by dx is equal to this one. This is our equation number 1. Now variable separable is not possible. Why? It is a sine square of y by x, and y by x is in angle form. We cannot separate it. So it is not, it will not come under the variable separable form. So we have to check whether it is homogeneous or not, right? For that, first you take your, what is your f of x comma y. F of x comma y is this one. Now you take f of kx, ky. So wherever y is there, there ky. Wherever x is there, there you have to take kx. So here kk cancels. Next, after this ky minus kx sine square y by x is there. So both are having k. So you take k outside. So y minus x sine square y by x by kx. Okay. So now you take the power a to the power of m by a to the power of m, k to the power of 1 by k to the power of 1. That is k to the power of 1 minus 1. That is k to the power of 0. Okay. And if you observe the remaining equation, that is exactly your f of x comma y, isn't it? So it is satisfying the homogeneous condition. So if any function can be written in this form f of kx comma ky is equal to k to the power of 0 into f of x comma y, then it is called the homogeneous equation of degree 0, isn't it? So whenever it is homogeneous equation, in all the problems it is common, first we have to check whether it is homogeneous or not. For that we have to take f of kx comma ky, then we have to get that value equation is equal to k to the power of some value into f of x comma y, then we can say that the given function is homogeneous equation. Once it is homogeneous equation, we have to take y is equal to Vx. In all homogeneous problems, confirmed it is homogeneous means you have to take y is equal to Vx. Once you have taken y is equal to Vx, then you take dy by dx. Okay, with that you take dy by dx is equal to d by dx of Vx, product of two terms, right? So this is derivative of product form, keeping one term as it is, differentiating the second term, plus keeping the second term as it is, differentiating the first term. With that you will get your dy by dx. So once you got dy by dx, you take your equation number 1. In this dy by dx place, right side we have to take v plus x into dv by dx, and here, right, wherever y is there we have to take vx in that equation. So then xx will get cancelled. If you observe, here x is there, here x is there, two terms are having common value, we can write outside, x is taken outside, then it is v minus sine square v by x, xx will get cancelled. Now send this v to the other side, x dv by dx is equal to minus sine square v. Okay, so now if you observe, some v terms are there, some x term dx, some dv, right? So v terms into dv, x term into dx. So minus integral 1 by sine square v dv is equal to integral dx by x. So integral dx by x is log x, and integral 1 by sine square is cosec square v, right? So integral cosec square is minus cot v, so this is minus already. So cot v is equal to log x plus c is the solution, but v is there, right? Our question is in terms of x and y, so answer also should be in terms of x and y. So that's why in v place you substitute y by x. Okay, but here one more thing is there, the solution of this differential equation passes through 1 comma pi by 4. So this solution passes through 1 comma pi by 4. Wherever x is there, there comes 1, right? Wherever y is there, there comes pi by 4. Okay, so it is nothing but cot of y by x, y is pi by 4, x is 1, okay, is equal to log x, x means 1 plus c, right? So that means it passes through that point, means point satisfies that equation. Okay, so then pi by 4 by 1 means pi by 4, pi by 4 means 45, cot 45, tan 45 values are equals to 1, so this is 1, and log 1 is 0, always it is one formula, just like formula we can remember, log 1 is equal to 0, okay, so 0 plus c, so c is equal to 1. So we got the c value, therefore the required solution is, our solution is in terms of c, isn't it? Cot of y by x is equal to log x plus c. In that c place you substitute 1, that will be your answer. Okay, so be careful while solving this problem. Be attentive, not careful, right? If you are attentive from the beginning to ending, it will comes very smoothly, right? So same procedure for all homogeneous problems. What is the procedure? First, what is the first thing? In these homogeneous problems, we have to check whether the given problem is homogeneous, given function is homogeneous or not. right? For that one condition it has to satisfy. What is that condition? F of kx comma ky is equal to k to the power of alpha into f of x comma y. That condition it has to satisfy. If that condition is satisfied, it is called homogeneous equation of degree, right, alpha, where alpha, what is alpha? Alpha can be any value 0, 1, 2, 3, 4, right? So we can say that this is the homogeneous equation with the degree alpha. Once it is confirmed homogeneous equation, in that given equation we have to take y is equal to vx. With that y is equal to vx only, we have to find dy by dx. Once we got dy by dx in the original equation, dy by dx place we have to substitute the derived value, and in the given equation wherever y is there we have to take vx and simplify all the terms. That means at the end it will have dv and dx terms. There will be no y terms. So after the simplification, after the substitution of y is equal to vx, your problem will be in terms of x and v only. X terms, v terms, dv, dx. So we can separate all the v terms together into dv, all the x terms into dx. Nothing but variables are separated. So variable separable method. Now take the integration for both. Right. If taking integration on both sides, you will get one solution. Right. But in this question it is given that generally we will stop there. But in this question it is given that the solution passes through the 1 comma pi by 4. So in the given solution, wherever x is there we have to substitute. Passes through means that point satisfies that solution equation. So in x place you have to take 1 and in y place you have to take pi by 4. Then you will get your c value, again substitute. That will be your required solution equation. Okay, so if you know the method, right, clear with the method how we have to solve. So when we can say the function is homogeneous, two things you should know, then you can easily solve these problems. Once again, this is also your 7-mark problem. Okay, so all homogeneous problems are 7 marks problems. Okay, so remember this one is also 7 marks problems. Okay, so practice this problem perfectly. That's all for today. Have a nice day.